So I'm going to start using these words regularly to talk about how sides relate to that given angle. So this is my angle theta. I have three similar triangles. I have the small one, the medium-sized one, and the big one containing the other two. And thinking about this angle theta, they all share the same kind of relationship with that. If I think about AE, that side is adjacent. I'm just going to label that with A. Actually, I'm going to call it A1. That's this side. Then I think about the medium-sized triangle going from A to D. I'm going to call that A2. And then I'm going to do the same thing for this big triangle, A to B. I'll call that A3. I'm going to do the exact same thing for these opposite sides, the sides that are diagonally opposite or across from that angle. So I'm going to call this O, or opposite 1, opposite 2, opposite 3. I'll call this hypotenuse 1, hypotenuse 2, and hypotenuse, or H3. So really the whole point of this is so that I can show that these ratios between these triangles are the same, and actually it's basically just going to segue into a naming convention for those ratios. So first I'm going to actually just compare my opposites and my adjacents. Since these are similar triangles, these ratios remain the same. So I could say O1 over A1 equals O2 over A2, and then equals, oops, that's supposed to be 3, O3 over A3. That ratio remains intact because these are similar triangles. The exact same thing happens with any pairs that I use. I could use the opposites over hypotenuses, or the adjacent sides over their hypotenuses. And these ratios consistently remain the same, and they come up so often that we actually came up with names for them. So when we're talking about each of these ratios as the opposite side over the adjacent side, or the opposite side compared to that angle, we're talking about the side that's opposite over its hypotenuse, or the side that's adjacent over its hypotenuse. These ratios remain consistent, and they're so important that we came up with names for them. Now, of course, mathematicians can't just come out and say a name. You have to abbreviate it with function notation. So actually, that's exactly what's going to happen here. Even though these first ones that we learned about are not technically functions, but they still use that function notation. It's the name of the function, the input, and then the output on the other side of the equal sign. So it's just important that you're familiar with how this is formed. We're going to have a name, and then sometimes actually we don't even include these parentheses, but the input goes there. Here a lot of the times we're going to see that as theta. And then the output, in this case, actually it's going to be a ratio of one side to another side. So these are our first trig identities, or some of the time I might even call these trig functions, even though as they stand right now, they're actually not functions, they're just using function notation. So sine of theta, that means my input is theta, or an angle. My input is an angle, and my output is the ratio between these two sides, the opposite and my hypotenuse. Cosine of theta, again, the input is an angle. Now I'm just talking about a different ratio, the adjacent compared to the hypotenuse. Then tangent of theta, again, same input, different output. Now we're talking about the opposite over the adjacent sign. So each of these names just talks about a specific ratio within a right triangle. It uses an angle as the input and a ratio as the output.